Hello students, welcome to Vyas Edification Kota. In this series of NCERT discussion, we are on NCERT class 12th, and in mathematics, the chapter that we are dealing with today is matrices. Matrices chapter we have started and we have discussed exercise 3.1, 3.2. Now we are moving to exercise 3.3 and let's discuss the first question after this. What does the question say? Find the transpose of each of the following matrices. Okay, person is talking about transpose. What do you mean by transpose? Transpose of a matrix implies that you form a new matrix by interchanging the rows and columns. What does that mean? If let us say you have a matrix A, B, C, D, E, F. So this here is the first row, this here is the first column, second row, this here is the first column, second column and third column, right? The rows and columns are interchanged and what you get after that is the transpose of this matrix, which is represented by A prime. This is A transpose, or it may be represented by this symbol. A, and in the superscript you have a T, or in the superscript you have a prime over there, A prime or A T. In this manner, right? This is A transpose, which is obtained by interchanging the rows and columns, right? The first column becomes the first row. This AD becomes the first row over here. The second column becomes the second column becomes the second row. The third column becomes the third row, and correspondingly what has happened is this first row has become the first column, the second row has become the second column, as you can clearly observe over here. The order also changes. This was a 2 by 3 matrix, this is a 3 by 2 matrix. The number of rows and number of columns get interchanged, as you can see very well that we are interchanging the rows and columns, and yes, that is how we get the transpose of any matrix. That's the idea behind the transpose. That's how we define the transpose of a matrix. Right. Once you're through with this definition, can we find the transpose of this matrix? Yes, we can do that very easily. Let's try to find the transpose of this matrix over here. This is a matrix. Let A equals 5, 1 by 2, minus 1. This is a matrix A. Then transpose of this matrix. Then transpose of this matrix A prime would be equal to what? This A prime would be actually, this is a 3 by 1 matrix, this would be a 1 by 3 matrix, okay? The first column becomes the first row, this is 5, 1 by 2, minus 1, and this is my transpose of that given matrix, as you can clearly observe over here. Is that all? Yes, that is all for this question. Let us talk about this one. We have another matrix and we are supposed to find the transpose of this matrix. Let B is this matrix. Let this matrix be named B. Then B transpose is equal to what? B transpose is simply replace the first row by the first column. This first row becomes the first column. The second row becomes the second column. This is what I get, and that's the transpose of this given matrix. That is all? Yes. Let's talk about this part next, third part for this question. We are once again finding the transpose of the matrix. How do we go about finding this? Let matrix C. This matrix is called C. Let this matrix be called C. This is minus 1, 5, 6. This is root 3, 5, 6. This is 2, 3, minus 1. Then C transpose is obtained by interchanging the rows and columns. The first row becomes the first column. The second row becomes the second column. The third row becomes the third column. And this is my answer for this question over here. Let's discuss this question next. If A equals this matrix and B equals this big matrix, then verify that. We have to verify two properties of transpose, right? These are some properties of transpose, that is, A plus B transpose is equal to A transpose plus B transpose. A minus B transpose is A transpose minus B transpose. We have to verify these two properties for these given matrices. Alright. So let's talk about the first part. What do I need in the first part? For the LHS, I need first A plus B, and then I will take the transpose of that. For the RHS, first I need A transpose, then I need B transpose, and after that I will add them together to get A transpose plus B transpose, which is the RHS. So first let's talk about the terms in LHS. What do we need? We need A plus B. Let's solve for A plus B. First find A plus B. A plus B will be obtained by adding the corresponding elements of these two matrices. Let's add the corresponding elements. Minus 1, minus 4. The sum is minus 5. 2, 1 will be added to 3. 3 minus 5 would be minus 2. What else? 5, 1 is 6. 7, 2 is 9. 9, 0 is 9. Minus 2, 1 is minus 1. 1, 3 is 4. 1, 1 is 2. This is what I have. This is A plus B for me. Therefore, LHS, which is equal to A plus B transpose, this becomes equal to what? This is a transpose of this matrix, and this is obtained by interchanging the rows and columns. This is minus 5, 3, minus 2, 6, 9, 9, and minus 1, 4, 2. This is A plus B transpose, which is there in the LHS. Now what about RHS? Let's find A transpose and P transpose first. For RHS, let's find A transpose and B transpose first of all. So A transpose is equal to what? A transpose is obtained by interchanging the rows and columns of A, matrix A, minus 1, 2, 3. The first row becomes the first column. The second row, 5, 7, 9 becomes the second column. The third row becomes the third column. And B transpose is equal to this minus 4, 1, minus 5, 1, 2, 0, 1, 3, 1. That means the first row becomes the first column, the second row becomes the second column, third row becomes the third column. We have interchanged the rows and columns. Therefore, RHS, that is equal to A prime plus B prime, becomes equal to what? This is equal to the sum of these two matrices. Let's add the corresponding elements. This is minus 1, minus 4, which becomes minus 5. This is 2, 1, which becomes 3. This is 3 minus 5, which becomes minus 2. This is 5, 1, which becomes 6. 7, 2 becomes 9. 9, 0 becomes 9. What about the last column? Minus 2, 1 becomes minus 1. 1, 3 add up to 4. 1 and 1 add up to 2. This is what I have. Right? And compare equation 1 and equation 2. What can you observe from equation 1 and equation 2? Can you observe that this is minus 5, 6, minus 1. This is 3, 9, 4. This is minus 2, 9, 2. The two matrices obtained at this location at the end of LHS, at the end of RHS. Basically, LHS and RHS, the two matrices are actually same. So, from 1 and 2, you can comment that LHS is equal to RHS, hence that's all. Yes, that is all for this question, as you may clearly observe. But this is just the first part. We are still to prove the second part. Let's focus on proving the second part now. How do we go about proving that? Let's begin with the second part after this. What does the second part say? We are supposed to find A minus B first of all, and we are supposed to take the transpose of that A minus B. That will further be equal to A transpose minus B transpose as per the comments, as per the question given there. So we are supposed to verify that this is equal to this. Okay. And how do we do that? We'll find A minus B first, right? Let's find A minus B. A minus B will be obtained by taking the difference of these two. Yeah. And what is the difference? Minus 1 minus of minus 4. What will that become? Minus 1 plus 4. That is 3. Okay. 2 minus 1, which will become 1. 3 minus of minus 5, which will become 8. Okay. This is what I have. 5 minus 1, which will become 4. 7 minus 2, which will become 5. 9 minus 0 will remain 9. Minus 2 minus 1 will become minus 3. This element 1 minus 3 will become minus 2. 1 minus 1 will become 0. This is A minus B for us. Therefore, LHS, the term in the LHS which is A minus B prime, is equal to what? This is equal to The transpose of this is 3, 1, 8. First row becomes the first column. 4, 5, 9. The second row becomes the second column. -3, -2, 0. This becomes the third column over here. Right? Is that all? Yes, that is all, as you can see clearly. What next? This is A minus B and A minus B transpose. On the right hand side, I need A transpose and B transpose, and then I need to take the difference of these two. So let's focus on finding A transpose and B transpose first. A transpose is equal to what? A transpose is the transpose. Let's find the transpose. This is -1, 2, 3, 5, 7, 9, -2, 1, 1. This is what I have for A transpose. And B transpose is equal to what? B transpose is -4, 1, -5, 1, 2, 0, 1, 3, 1. This is what I have in B transpose. Using these two, we can find A transpose minus B transpose. What is that equal to? Let's take the difference of these two. -1 minus of -4. What will that be? -1 plus 4, which is 3. Okay. 5 minus 1, which is 4. -2 minus 1, which is -3. 2 minus 1, which is 1. 7 minus 2, which is 5. 1 minus 3, which is -2. 3 minus of -5 will become 8. 9 minus 0 is 9, and 1 minus 1 is 0. You can observe this. Now, this is, let us say, statement 1, and this is, let us say, statement 2. Can you observe the matrices obtained at the end of this? This is 3, 4 minus 3, 3, 4 minus 3. 1, 5 minus 2, 1, 5 minus 2, 8, 9, 0, 8, 9, 0, and yes, these two matrices that we have obtained are exactly same. So from 1 and 2, we observe that A minus B transpose is equal to A transpose minus B transpose, hence verified. We have verified this condition, this property for these two matrices. Let me get aside for a bit and you can take a look at the complete solution once again. That is all for this question. Let's discuss this question next. What does the question say? If A transpose is equal to 3, 4, minus 1, 2, 0, 1 and B is equal to this matrix, okay, then verify that. Okay, we are supposed to verify the properties of transpose for these matrices. Let's try to do that. And there are two parts. Let's try to solve them one by one. We have to verify that these properties are true for these matrices as well. Okay, let's begin with the first part. How do we approach the first part? For the first part, what I need is, on the LHS, I have A plus B and then I take the transpose. Now, am I given A over here? No, I am given A transpose over here, but I am given B. So first, let me find A using this A transpose. Given A transpose is equal to this matrix 3, 4, minus 1, 2, 0, 1 implies matrix A would be equal to what? Matrix A is the transpose of this matrix, which will be the first row becomes the first column, the second row becomes the second column, the third row becomes the third column over here, right? Given A prime equals to this, we get A equal to this, and B is already known. B is already known to us. B is minus 1, 2, 1, 1, 2, 3. This is given. So therefore, I can easily find A plus B. A plus B will be equal to the sum of these two. 3 minus 1, which is 2. Minus 1 plus 2, which is 1. 0 plus 1, which is 1. 4 plus 1, which is 5. 2 plus 2, which is 4. And 1 plus 3, which is 4. This is matrix A plus B. This is sum of matrices A and B. And from here, I can get A plus B transpose very easily. What will A plus B transpose look like? A plus B transpose would be the transpose of this matrix over here. This is 2, 1, 1. The first row becomes the first column. And 5, 4, 4. This second row becomes the second column. This is my matrix A plus B whole transpose, as you can clearly observe. Let us call this equation number 1. Next, let us talk about the terms in the RHS. Now, what do we have in the RHS is A prime and B prime, okay, and A transpose, that is already given to us. Let's find B transpose first of all. Okay. So for the RHS, let's find B transpose. Since B is given, what is B? Minus 1, 1, 2, 2, 1, 3. This is given. Implies B transpose is equal to minus 1, 2, 1. The first row becomes the first column and the second row becomes the third column. B transpose equal to this. Also, comma A transpose is equal to what? A transpose is given. This is 3 minus 1, 0, 4, 2, 1 and this is given. Okay. Therefore, A transpose plus B transpose is equal to what? This can be found easily, yes. A transpose plus B transpose can be found by adding the corresponding elements. Let's do it. 3 minus 1 which is 2, 4 and 1 which is 5, minus 1 and 2 the sum is 1, 2 and 2 the sum is 4, 0, 1 the sum is 1, 1, 3 the sum is 4. This is what I obtain and let's call this statement 2. Now observe the matrices obtained at the end of 1 and at the end of 2. This is 2, 5, 1, 4, 1, 4, 2, 5, 1, 4, 1, 4. The two matrices are exactly same and this is what we started with. We wanted to prove this particular result, that is A plus B whole transpose is equal to A transpose plus B transpose, which is true for these two given matrices here, right? So from 1 and 2, A plus B whole transpose is equal to A transpose plus B transpose. This is hence verified. This is completely verified, right? And that is all for this part over here. This is the first part of this question. Next, we'll take a look at the second part. Now, what does second part say? It says that A minus B transpose, whole transpose, should be equal to A transpose minus B transpose. So, once again, we'll begin with finding A first. Since A transpose is given, A is not given, we'll find A using this A transpose, right? So, since for the second part, since A transpose equals, this is 3 minus 1, 0, 4, 2, 1, comma then since A transpose is already there, then A, the matrix A will be equal to what? The matrix A can be easily obtained. This is 3 minus 1, 0. The first column becomes the first row, the second column becomes the second row. This is matrix A, okay? And matrix B is already given. Matrix B is already known to us. This is minus 1, 2, 1, 1, 2, 3. This is already given to us. This matrix is already given. Okay. Can we find A minus B very easily? Yes. Therefore, A minus B is equal to what? A minus B will be obtained by subtracting this and this. Now, 3 minus of minus 1. What will that be? 3 minus of minus 1 becomes 3 plus 1, which is 4. Minus 1 minus 2 will become minus 3. 0 minus 1 will become minus 1. This is what you'll be getting. What next? 4 minus 1 is equal to 3. 2 minus 2 is 0. 1 minus 3 is minus 2, and that is what I get over here. This is the matrix A minus B. Now, using this matrix A minus B, can we further find A minus B transpose, whole transpose? Yes, we can easily find that. This implies A minus B whole transpose is equal to the transpose of this matrix. What is that? The first row, 4 minus 3 minus 1 becomes the first column. The second row, 3, 0 minus 2 becomes the second column. And let's call this statement 1. Let us call this statement 1, right? This is A minus B whole transpose. What about the RHS? For the RHS, we want A prime and B prime. That is A transpose and B transpose. A transpose is already given. And using B, can I find B transpose? Yes. Let's try to find B transpose. Since B, matrix B is given to us, what is that? Minus 1, 2, 1, 1, 2, 3. This is given. Then B transpose is equal to what? This is minus 1, 2, 1, 1, 2, 3. This is the matrix B transpose, right? Since B is equal to this matrix and B transpose, therefore would be equal to this matrix. Can we find A transpose minus B transpose very easily? Yes, that's what is required. So therefore A transpose minus B transpose is equal to what? A transpose is already known, given. This is 3, 4, minus 1, 2, 0, 1. This is the matrix over here. And what is B transpose? B transpose has already been found. Let's use that. 2, 2, 1, 3. This is what I get. And this is further equal to, this gives me A transpose minus B transpose is equal to this matrix over here. 3 minus 1 will become 4. 4 minus 1 will become 3. Minus 1 minus 2 will become minus 3. 2 minus 2 is 0. 0 minus 1 is minus 1. And 1 minus 3 is minus 2. This is what I obtained. This is second statement. Now let's take a look at the matrices obtained at the end of first and the end of second. What do we have? This is 4, 3, minus 3, 0 and minus 1, minus 2. These are exactly same, and yes, from 1 and 2, we can say that this property has been verified. What's the property? A minus B whole transpose is equal to A transpose minus B transpose. Mind you, we are simply verifying this property. It's not the proof of this property. This is a simple verification of this property over here, right? So we have verified these two properties for this given question over here. Let me get aside so that you can take a look at the complete solution, right? And that is all for this question over here. Let us talk about this question. If A transpose is minus 2, 3, 1, 2 and B is equal to minus 1, 0, 1, 2, then find this matrix over here. How do we go about finding A plus 2B whole transpose? We'll go step by step. Let's follow steps. For finding this, we need A first. We already have B, we need 2B first. Okay, and then we'll have to add these matrices and then take the transpose. Okay. So given, solution says given A transpose is equal to minus 2, 3, 1, 2. Can we find matrix A very easily? Yes, matrix A is the transpose of this matrix, right? Let us remember that matrix A will be equal to the transpose of transpose, right? The transpose of transpose. And this is obtained by interchanging the rows and columns. This is minus 2, 3. This is 1, 2. This is what I get. This is matrix A. Okay. And can we find 2B as well? Yes. Since matrix B is given as minus 1, 0, 1, 2, this implies that the matrix 2B will be equal to minus 2, 0, 2, 4. This is the matrix 2B equal to, right? Using this statement 1 and this statement 2 over here, right? Equation 1 and plus equation 2. What does that give me on the LHS? I have A and 2B. Implies A plus 2B is equal to what? The sum of these two matrices over here. Can we easily find the sum? Yes. What is the sum? This is minus 2, this is minus 2, this becomes a minus 4. This is 1, this is 0, this becomes a 1. This is 3, this is 2, which becomes a 5. This is 2, this is 4, which becomes a 6. And yes, this is the 2 by 2 matrix, that is what we obtained. This is A plus 2B is equal to this 2 by 2 matrix. What next? Can we take the transpose of this? Yes. This implies next. Therefore, on taking the transpose, what we obtain is interchange the rows and columns, and the matrix that is obtained is this. The first row becomes the first column, the second row becomes the second column, and yes, that is the final answer for this question. Let me get aside for you to take a look at this complete solution. That is all for this question over here. Let us talk about this question. For the matrices A and B, verify that AB whole transpose is equal to B transpose times A transpose. Okay, this is a property of transpose, and we are supposed to verify this property for these two given matrices. Okay, this is the first part. Let's try to solve this and prove this. Verify this basically. How do we go about doing that? So in the LHS, as you may observe, you have the product AB. First, we have to find the product AB, and then we have to take the transpose of that. Okay. For the RHS, we have to take the transpose first and then find the product. Okay. The product B transpose times A transpose. Okay. Let's try to do it. So given matrices A and B, can I easily find the product first? Okay. So given A equals this matrix 1 minus 4 3 and B equals minus 1 2 1. Given these two matrices implies product AB will be equal to what? Product AB is 1 minus 4 3 times minus 1 2 1. This is the product. What will this product be equal to? Okay. For multiplying this is a 3 by 1 matrix, this is a 1 by 3 matrix. Okay. Is this matrix product, does this matrix product exist? Yes. Are these matrices, the product can be found for these? Yes. These two numbers are same, that is the number of columns in this will be equal to the number of rows in this. Yes. And therefore the matrix product exists. And what will be the final order of the product? The final order would be 3 by 3. So we will get a 3 by 3 matrix. Okay. A big matrix, 3 by 3 matrix. What is that matrix equal to? Let's take a look at this. The first row gets multiplied with the first column to give us this element. So 1 gets multiplied with minus 1. There's nothing to add after that, right? This is minus 1. Next, 1 gets multiplied with 2, we get 2. 1 gets multiplied with 1, we get 1. This is the first row. Second row, for second row, minus 4 gets multiplied with minus 1, we get 4. Minus 4 times 2, which is minus 8, minus 4 times 1, which is minus 4. Next, 3 times minus 1, which is minus 3, 3 times 2, which is 6, and 3 times 1, which is 3. This is what I have, right? So this is the product AB. Once you have the product AB, implies the product AB and its transpose, right? AB whole transpose can be found very easily by, let's get rid of this is not required. AB transpose is found by interchanging the rows and columns. The first row becomes the first column, as you can see. The second row, 4 minus 8 minus 4 becomes the second column. The third row becomes the third column. This is what I have. This is what I have at the end. What next? So on the RHS, you have something else. This is the first statement, right? This is the end product, end result for the LHS. For the RHS, first we need B transpose. Okay. So, okay. Given we are already given that B equals this, or we can say this is statement 1. Let's call this statement 2. So from statement 1, we get B transpose easily. What is B transpose? Is equal to B transpose is the transpose of this. This becomes minus 1, 2, 1. And A transpose is equal to the transpose of that matrix. This is 1 minus 4, 3. This is what I get. This is the transpose of this column matrix becomes a row matrix, and the transpose of this row matrix becomes a column matrix, as you can clearly observe over here. Using B transpose and A transpose, therefore, the product B transpose, A transpose. Please observe, B transpose has to come in front, A transpose has to go at the back, and B transpose is pre-multiplied actually. What you obtain from here is, this is minus 1, 2, 1 times 1 minus 4, 3. This is what I get, and let's multiply them together. This is again a 3 by 1 matrix, 1 by 3 matrix. The final matrix that will obtain will be a 3 by 3 matrix. Yeah, that's what we want, right? Let's see, the products would also look similar. This is minus 1 times 1, which is minus 1. First row, second column, that becomes 4. First row, third column, that becomes minus 3. Okay. Second row, first column 2. Second row, second column, minus 8. Second row, third column, which is 6. Third row, third row, first column, which is 1. Third row, second column, minus 4. Third row, third column, which is 3. This is what I obtained. Right. This is B transpose times A transpose. That's what I obtained. Okay. This is statement 2. Sorry, this is statement 3. Let's see. And let's observe the matrices obtained at the end of statement 2 and statement 3. This is minus 1, 4, minus 3. Okay, that matches. The second row, 2 minus 8, 6 also matches. The third row, 1 minus 4, 3 also matches. And yes, we can say from 2 and 3, what do we observe? We observe that AB transpose is equal to B transpose, A transpose. Hence, it has been verified. It has been verified. Okay, let me get aside so that you can take a look at this question. And let's move on to the next one after this. This is part 2 for the same question. What does the part 2 say? We have a matrix A, we have another matrix B, and we have to verify that the product A, the transpose of product AB is equal to B transpose, A transpose. Let's do that. So matrices A and B are given to us, okay, and using these matrices we'll first find the product AB, then take its transpose, okay. So let's do it. What do we have over here is given A equals 0, 1, 2, comma B equals 1, 5, 7. Let's call this statement 1. Given these are the two matrices, we are supposed to find the product AB, okay. Let's find the product AB then. This implies AB, the product AB can be written as 0, 1, 2 and multiplied with 1, 5, 7. Now this is a 3 by 1 matrix, this is 1 by 3 matrix. The product exists and the final order of the matrix would be 3 by 3. That's what you can observe. And what will that 3 by 3 matrix be? First row gets multiplied with first column to give us this. This is 0, the first row. Second column gives again 0. 0 times 7 is also 0. Second row with the first column, second column, third column will give us the second row. 1 times 1 is 1, 1 times 5 is 5, 1 times 7 is 7. Third row, 2 times 1 is 2, 2 times 5 is 10, 2 times 7 is 14. This is my matrix AB. And after you have obtained the matrix AB, can we find the transpose of AB? Therefore, AB transpose, take the transpose, and what you get by taking the transpose is 0, 0, 0 over here, 1, 5, 7 over here, 2, 10, 14 over here. This is the matrix. Let us call this statement. Let's call this statement 2. Okay. What else? Now using this statement, I can find B transpose and A transpose first of all, then take the product for getting the RHS. Yeah. So let's do it. Using 1, I can find A transpose is equal to what? A transpose would be 0, 1, 2. These elements would be present over here. And B transpose is equal to what? B transpose would be 1, 5, 7. Okay, B transpose would be 1, 5, 7. After that, we can get B transpose times A transpose. Therefore, B transpose, A transpose, the product, B transpose, A transpose would be equal to what? Let's find that. B transpose is 1, 5, 7. A transpose is 0, 1, 2. And the product can be found very easily. This is 3 by 1, this is 1 by 3. The final product would be a 3 by 3 matrix. 1 times 0 is 0, 1 times 1 is 1, 1 times 2 is 2. 5 times 0 is 0, 5 times 1 is 5, 5 times 2 is 10. 7 times 0 is 0, 7 times 1 is 7, 7 times 2 is 14. This is what I have. And this is the product B transpose, A transpose. And let's call this statement 2. Let's call this statement 3. Okay. And observe the two matrices obtained at the end of 2 and 3. This is 0, 1, 2, 0, 5, 10, 0, 7, 14, 0, 1, 2, 0, 5, 10, 0, 7, 14. They are exactly same. Therefore, from 2 and 3, equation 2 and 3, we can say that this property AB whole transpose is equal to B transpose A transpose is true for these two matrices. We have verified that this property holds for these two matrices as given, right? Let us discuss this question. If first part says A equals cos alpha sin alpha minus sin alpha cos alpha, okay, then verify that A transpose times A is equal to identity matrix I. Okay, for this matrix A, we are supposed to verify that this holds. How do we verify that? Let's take a look at this matrix. This is question 6th and part first only. So matrix A given A equals this matrix, which is cos alpha sin alpha minus sin alpha cos alpha. Okay, given matrix A is this. Therefore, A transpose, the matrix A transpose would be equal to what? The matrix A transpose would be the transpose of this matrix. This is cos alpha sin alpha over here. The first row becomes the first column, the second row becomes the second column. This is what we have. Therefore, A and A transpose are obtained, and therefore A transpose A, this implies A transpose A would be equal to what? A transpose A would be equal to the product of this and this. This is cos alpha. Let's write the product minus sin alpha, cos alpha times this. This is cos alpha, sin alpha minus sin alpha, cos alpha. Okay, this is the product. And let's multiply them together. What do we obtain by multiplying them together? Which implies A transpose A is equal to what? Observe carefully. This cos alpha times cos alpha, which is cos square alpha, minus sin alpha minus sin alpha. The product would be plus sin square alpha. This becomes cos square alpha plus sin square alpha. Okay. What next over here? This is cos alpha times sin alpha minus sin alpha times cos alpha. Pretty interesting. Cos alpha sin alpha minus sin alpha cos alpha. That will be simply 0. Let me write a 0 over here. This is second row, first column will be sin alpha cos alpha times minus sin alpha, which is sin alpha cos alpha minus cos alpha sin alpha. The overall sum would be 0. Okay. Sin alpha times sin alpha, which will be sin square alpha, and plus cos square alpha. This will be sin square alpha plus cos square alpha. And what is this equal to? Sin square theta plus cos square theta is simply 1. This is 1, 0, 0, 1. This is what I obtain. And yes, this is the identity matrix. This is identity matrix of order 2. This implies that A prime A is equal to A transpose A. The product is equal to identity matrix. And yes, this is what we want to do. Verify. Hence, verified. Right? You may observe that we are asking, the person is asking us to verify this result, because this particular thing is not true in general. This particular thing is true for this matrix, right? For this particular matrix over here, and that's what we have proved. Right. Now this is 6th part 1. Let's see the 6th part 2 after this. What does 6th part 2 say? Let's take a look at this. 6th part 2 says that we are given another matrix A, and then we are supposed to verify, okay, A transpose A is equal to I. We are supposed to verify a similar kind of an expression, similar, exactly same as part 1. So begin with A, okay, given A equals sin alpha cos alpha minus cos alpha sin alpha, and this particular thing implies A transpose would be equal to what? A transpose would be equal to sin alpha. This first row becomes the first column, cos alpha minus cos alpha sin alpha. Okay. Using this, therefore, A transpose A. What is this? This is the LHS of that expression which we have to verify. So let's write A transpose times A. What is this equal to? This is A transpose. This is sin alpha minus cos alpha sin alpha times this here, which is sin alpha cos alpha minus cos alpha sin alpha. Let's multiply them together. What do we get? The product will be another 2 by 2 matrix. What does that look like? The first row gets multiplied with the first column. You multiply sin by sin, we get a sin square alpha. Minus cos alpha, the product would be plus cos square alpha. Okay. Sin alpha times cos alpha is what I obtain over here. Minus cos alpha times sin alpha. Okay. This is the second term over here, right? What next? Cos alpha times sin alpha. And minus sin alpha times cos alpha. This is what I obtain. Right. What next? The second row gets multiplied with the second column. Cos alpha times cos alpha is cos square alpha. Sin alpha times sin alpha is plus sin square alpha over here. This is what I obtain. And after reaching this stage, you can observe that sin alpha, cos alpha, this and this get cancelled, this and this get cancelled. This term becomes 0, this term also becomes 0, which gives A prime A, this is A transpose A, is equal to what? This here, sin square theta plus cos square theta is always 1. That's sin square alpha plus cos square alpha is equal to 1. This is 0, this is 0, this is 1. You can observe this is cos square alpha plus sin square alpha, which is also 1. And this implies that A transpose A is equal to identity matrix, and that's what we wanted to verify. Have you verified this? Yes. Take a look at this complete solution once, and that is all in this question. Let's talk about this question, 7th part 1. What does part 1 say? Show that the matrix A equals this is a symmetric matrix. Okay. Now, what do you mean by symmetric matrix? If you may recall from the definition of symmetric matrices have something to do with transpose, right? And when we talk about symmetric matrix, what happens is that on taking transpose, the matrix remains same. What do you mean? For symmetric matrix or for a matrix, square matrix A, if A transpose is equal to A, if A transpose is equal to A, then A is called a symmetric matrix. Then the matrix A is said to be a symmetric matrix. Okay. There's another thing called a skew symmetric matrix. Now, what will happen in case of a skew symmetric matrix? Skew symmetric matrix, in case of a skew symmetric matrix, if A transpose becomes equal to minus A, then matrix A is called a skew symmetric matrix. Then the matrix is called a skew symmetric matrix. Here in this particular question, we are supposed to check whether, or we are supposed to show that this is a symmetric matrix. Now, although it is very simple to observe a symmetric matrix from the outside, because for a symmetric matrix, the most important thing that you have is, first of all, these diagonal elements can be anything, that's not an issue. But other than that, mirror images of the elements across the diagonal. Basically, these two elements should be exactly same. That is, when we take a mirror image along the diagonal, we should get basically the same thing, right? These two parts should be mirror images of each other with respect to this diagonal. That's important. That is, these two elements should be exactly same, and you can observe, yes, this particular matrix is symmetric about this main diagonal, right? Since this matrix is symmetric about this main diagonal, this is called a symmetric matrix, and this is true for such matrices having this kind of a thing. A transpose is equal to A for such matrices, right? So that's the idea behind all of this. We can identify this as a symmetric matrix, but for proving this, we have to use the basic definition. And what's the basic definition say? Basic definition says that A transpose should be equal to A, right? So for showing that this is a symmetric matrix, given A equals this huge matrix over here, right? I'm not writing the matrix, we can always write that. To prove A is symmetric matrix, that is what we are supposed to prove. What does the proof look like? For finding the proof, it is sufficient to prove that A transpose is equal to A, right? That's the definition of symmetric matrix, right? So given A, we find given A, let me write 1 minus 1 5 minus 1 2 1 5 1 3. Okay, this is statement 1. So from equation 1 comma find A transpose. Now A transpose would be simply obtained by interchanging the rows and columns. What is that? 1 minus 1 5 minus 1 2 1 5 1 3. Okay, this is statement number 2. Using 1 and 2, can you observe that this is 1 minus 1 5, yes, minus 1 2 1 5 1 3, they're exactly same, yes. So using 1 and 2, we obtain that A is equal to A transpose. We obtain that A is equal to A transpose implies, since from the definition of symmetric transpose, this implies that A is a symmetric matrix. This implies that A is a symmetric matrix, right? This is what you want to prove. Yes, that's a complete proof for this one. And this is the first part of 7th question. Let's take a look at the next part. The second part of this 7th question. What does it say? Show that the matrix A equals this is a skew symmetric matrix. Okay. Now, what does a skew symmetric matrix looks like? Let's take a look at that. In a skew symmetric matrix, first of all, the diagonal elements are 0. The diagonal elements are all 0, and rest of the elements are actually anti-mirror images. What do you call anti-mirror images? Basically, they are negative of each other. If this is 1, this should be minus 1. If this is alpha, this should be minus alpha. If this is k, this should be minus k. If this is lambda, this should be minus lambda. The converse is also true. If this is lambda, this should be minus lambda, right? Corresponding elements, these two should be negative of each other. That's important, right? So this is a skew symmetric matrix, as you may clearly observe using this idea, but what is the definition say, right? This is true for 3 by 3, 4 by 4 when you observe that kind of matrix, but definition says that A transpose should be equal to minus A, right? So for that we'll have to find A transpose, we'll have to find minus A as well, and on the basis of that we'll have to comment, right? So given A equals 0, 1, minus 1, minus 1, 0, 1, 1 minus 1, 0, this is given to us. We can easily find A transpose is equal to, A transpose will be equal to 0, 1, minus 1. First row becomes the first column, minus 1, 0, 1 and 1 minus 1, 0. This is what I have. Let's call this statement 1. Therefore, A transpose is equal to this, and minus A equals what? Minus A is negative this, right? We'll have to multiply each element with a minus. So minus of 0 is 0, minus of 1 will be this, minus of minus 1 will become 1 in the first row. The second row, minus of minus 1 would become 1, minus of 0 would be 0, minus of this, minus 1, 1 and 0. This is what I obtained. This is statement 2. This is statement 2 over here. Now once we have statement 2 and statement 1, can you observe that A transpose and minus A are exactly same. So therefore, A transpose is equal to minus A from 1 and 2. This is what you can observe from 1 and 2. Yes, and this is the definition of skew symmetric matrix, that A is, if A transpose is equal to minus A, then A is skew symmetric matrix. Then A is a skew symmetric matrix, hence proved. This is what we wanted to prove. Yes, that is all for this question over here. Is that all? Yes. You can take a look at the complete solution, and I'll get aside for a minute. Let's discuss this question next. For the matrix A equals 1, 5, 6, 7, verify that A plus A prime is a symmetric matrix. Okay. A minus A prime is a skew symmetric matrix. Pretty interesting. We have to verify that for this square matrix A plus A prime is symmetric and A minus A prime is skew symmetric. Now this is based on a property once again. What does the property say? That for a square matrix A plus A prime will be symmetric, right? For a square matrix A. In general, A plus A prime would be a symmetric matrix and A minus A prime would be skew symmetric matrix. What are we supposed to do in this case? Let's try to solve using basic concepts, right? We are supposed to find this matrix first of all. Okay. So I'm focusing on the first part. A equals 1, 5, 6, 7. This is given to me. Okay, this is already given. On the basis of this, I can easily find A prime, which is 1, 5, 6, 7. Okay. And I can add them together. So let B is equal to A plus A prime. And what is that equal to? The matrix B would be sum of these two. 1 plus 1 is 2. 5 plus 6 is 11. 6 plus 5 is 11. 7 plus 7 is 14. And this is what I obtained. This is matrix B. This is matrix B. After this, therefore, B prime is equal to what? B prime is under the matrix 2, 11, 11, 14. What I've done is this first row becomes the first column, the second row 11, 14 becomes the second column over here. And you may observe that since B prime is equal to B, this is B prime and this is B, since B prime is equal to B implies B is a symmetric matrix. Implies B is a symmetric matrix. B, or what you have called A plus A prime. A prime is implies A plus A prime is a symmetric matrix. This implies A plus A prime is a symmetric matrix. And yes, that is all for the first part, as you may observe over here. Next, we are supposed to talk about A minus A prime. And can I continue from here only? Yes, we can continue from here only. We have already found A and A prime. So, for second part, this and this will be okay, but let C equals A minus A prime. Let C equals A minus A prime. Now, what is A minus A prime equal to? This will be equal to difference of these two. Okay, A minus A prime. 1 minus 1 will be 0. 5 minus 6 would be minus 1, 6 minus 5 would be 1, and 7 minus 7 would be 0. This is the matrix that I obtain over here. This is matrix C. And once I have C, implies C prime would be equal to what? Therefore, C prime is equal to, C prime would be actually equal to, this is 0, minus 1, 1, 0, okay. And what is minus C equal to? Since we are looking for skew symmetric, we'll have to find C prime and minus C and check whether they are equal or not. So minus C is equal to 0, minus or minus 1 will become 1, 1 times minus 1 will be this, and this is what I obtain. And you can clearly see that C prime and minus C are equal. Since C prime equals minus C implies C is skew symmetric matrix. Okay, pretty interesting. And C and what is C actually equal to? This implies A minus A prime is skew symmetric matrix. That's what we were supposed to verify. And have we verified this? Yes, this has been verified, as you can clearly see over here. Right? That's the complete solution for this question, and you can take a look at this complete solution for this question over here. Let us take a look at this question. Find half of A plus A prime, okay, and half of A minus A prime when A is this matrix. Okay, so let's try to find half of A plus A prime and half of A minus A prime. So given the matrix A, we'll have to find A prime first of all. Yes, that is A transpose. Let's try to find A transpose first. So A is already known, implies A transpose would be equal to what? Let's find A transpose. That will be 0 A B minus A 0 C minus B minus C 0. This is A transpose for us. This is first, this is second statement. Let's say these are the two statements, 1 and 2. Okay. Given A and A transpose, can we find, therefore half times A plus A transpose would be equal to half times the sum of these two matrices. Let's add these two matrices. 0 plus 0 is 0. A minus A would be 0. Oh, pretty interesting. B minus B would be 0. All the terms in the first row are 0. The second row, minus A plus A would be 0. 0 plus 0 would be 0. C minus C would be 0. Minus B plus B would be 0. Minus C plus C would be 0. And 0 plus 0 would be 0. Pretty interesting. This is coming out to be a 0 matrix. Yeah. Multiplied with half, what you get is another null matrix. The same null matrix, right? This implies half of A plus A prime is equal to this. This is what I get. This is the first matrix that was required, that was asked. What about the next one? Half of A minus A prime. So using 1 and 2, we can say, therefore, half of A minus A prime is equal to half of the difference of the two matrices A and A transpose. A minus A transpose. 0 minus 0, which is 0. A minus of minus A, what is that? A plus A, which is 2. 2A. Okay. B minus of minus B, what is that? 2B. Minus A minus A, which is minus 2A. 0 minus 0 is gone, 0. C minus of minus C, which is 2C. And minus B, which is minus 2B, minus C, which is minus 2C, 0 minus 0, which is 0 over here, right? This is what I obtain. Can I multiply it with half? Yes. What do we get on multiplying with half? This is a 0, this is A, this is B, this is minus A, this is minus B, this is minus C, this is 0, C, 0. That's what I obtain. And therefore, obviously, half of A minus A prime is equal to this matrix over here. That is what we were supposed to find. Yeah, we were supposed to find these two matrices. Now, what is the special thing about these two matrices? One thing which is special is for any square matrix A, A plus A prime is actually a symmetric matrix. A minus A prime is a skew symmetric matrix. What about this A? This A is a special matrix. It is in itself a skew symmetric matrix, you may observe, right? And on taking the symmetric matrix, converting it into a symmetric, writing it as, let us say A plus A prime, what do you get? A plus A prime is actually a null matrix. Is it symmetric? Yeah, it is symmetric. What about A minus A prime? This is also a symmetric, sorry, this is supposed to be skew symmetric. Yes, it is a skew symmetric matrix. There's no doubt about that. It is equal to that matrix only, right? And sum of these two over here, sum of these two, what is that? That's a null matrix plus this would be actually this matrix which is equal to A only. So the matrix A can be written as that is sum of a symmetric and a skew symmetric matrix. Any square matrix A can be written as a sum of a symmetric and a skew symmetric matrix using this idea, using these matrices over here, right? That is all for this question for now. Let's discuss this question. Express the following matrices as the sum of a symmetric and skew symmetric matrix. Okay. How are we supposed to do that? Okay. So, expressing any matrix as a sum of symmetric and skew symmetric matrix, we have a standard process. What does that standard process say? Let A is any matrix, right? For any matrix A is any square matrix. Okay. A can be written as the sum of this and this, right? This matrix here is a symmetric matrix, okay? Half times symmetric would be a symmetric. This matrix here is a skew symmetric matrix, half times this would be a skew symmetric matrix, and if you add them together, what you will get is A. I don't want to add them together. What I'm saying is the converse of that. I'm splitting A as sum of these two, and where this is a symmetric matrix and this here is a skew symmetric matrix. This here is a skew symmetric matrix. I am writing it as sum of this and this together. Can you please observe that? Yes. Pretty simple? Yeah, pretty simple for that matter. Express the following matrices as sum of symmetric and a skew symmetric matrix. That's what we have. Right. Keeping this in mind, can we continue further and express this matrix as sum of symmetric and skew symmetric matrix? Yeah, we can do that. Let's begin with assuming this matrix as A. So, this is the first part. Let A equals 3, 5, 1, minus 1. Once I have this, can I find A prime first? Yes, implies A transpose, that is A prime, which is equal to 3, 5, 1, minus 1. Okay, this is 1 and this is 2, let's say. Using 1 and 2, I'll have to find A plus A prime and multiply it with half. We'll also have to find A minus A prime multiplied with half as well. Okay, so therefore A plus A prime is equal to what? Half of A plus A prime is equal to what? Or we can say let P is a matrix which is half of A plus A prime. What is that? Half of the sum of these two matrices. What is that? 3 plus 3 is 6, 5 plus 1 is 6, 1 plus 5 is 6, and minus 1 minus 1, the sum is 2, minus 2, sorry. On multiplying it with half, this gives me P equals 3, 3, 3, minus 1. Okay. This is the matrix P. This is the matrix P. Observe that P prime is equal to 3, 3, 3, minus 1, which is equal to P only, and implies P is a symmetric matrix. Pretty interesting. We have found P and P is a symmetric matrix. What next? I know that I have to find another kind of matrix based on this A. What is that? Half of A minus A prime. Okay. Now let Q equals half of A minus A prime. What is that? Half of the difference of these two matrices, A and A transpose. 3 minus 3 becomes 0. 5 minus 1 becomes 4. 1 minus 5 becomes minus 4. And minus 1 minus of minus 1, that is minus 1 plus 1, becomes 0. Multiplied with half, that gives me Q equals 0, 2, minus 2, 0. Okay. And observe this matrix Q very carefully. Q transpose is equal to 0, 2, minus 2, 0. Okay. Let's take out a minus common. Oh, what do you mean by taking out a minus common? I am taking out a factor of -1 from each element. This is -1 times 0, 2, -2, 0. And this here is nothing but q. This is minus of q. Q prime is equal to minus q. If q prime is equal to minus q, implies q is a skew symmetric matrix. Q here is a skew symmetric matrix. Yeah, Q is a skew symmetric matrix. Once we have found that Q is a skew symmetric matrix, let's check. Let's check what is the sum of P and Q. Let's check the sum of P and Q. Now, P plus Q is equal to what? P is this 3, 3, 3 minus 1 plus Q is 0, 2, minus 2, 0. The sum, as you may observe, is 3 plus 0 is 3, 3 plus 2 is 5, 3 plus minus 2, 3 minus 2 is 1, minus 1 plus 0 is minus 1, and this is 3, 5, 1, minus 1, which is the original matrix that we started with. This is equal to A. Basically, A has been written as a sum of two matrices P and Q, where P is a symmetric matrix, Q is a skew symmetric matrix, using this idea and this idea over here. So the matrix A has been written as a sum of this and this matrix, right, where P is symmetric and Q is skew symmetric matrix. Is that all? That is all for this part over here. Let's move on to the next part for this question. The second part, what does the second part say? Once again, we have to write this matrix as a sum of symmetric and skew symmetric matrix. Now, since we have understood the process of writing it as a symmetric and skew symmetric matrix, what I'll directly find is half of A plus A prime and half of A minus A prime. Let's say, let A equals this matrix 6, minus 2, 2, minus 2, 3, minus 1, 2, minus 1, 3. This is what I have. Implies A prime would be equal to what? A transpose. That is 6 minus 2, 2, minus 2, 3, minus 1, 2, minus 1, 3. Okay, and using these two, let P equals half of A plus A prime and Q equals half of A minus A prime. These are symmetric and skew symmetric matrix. This is symmetric and this is skew symmetric matrix. P and Q are symmetric and skew symmetric matrices. Therefore, P equals half of sum of these two. What do you get? 6 plus 6 is 12. Okay. Minus 2, the sum is minus 4. 2 and 2, the sum is 4. Okay. Minus 2 and minus 2 over here is minus 4. My 3 and 3 over here is 6. Minus 1, the sum is minus 2. Okay. 2 and 2, the sum is 4. Minus 1, the sum is minus 2. 3 and 3, the sum is 6 over here. Pretty interesting. Why? Because, okay, this original question is a symmetric matrix in itself. Very interesting. Next, P is equal to half of this. This becomes equal to what? This becomes equal to 6 minus 2, 2, minus 2, 3, minus 1, 2, minus 1, 3. This is what I have. This is the symmetric matrix that you obtained, because this was the original question also is a symmetric matrix. So this is the symmetric matrix, same as A. What about Q? If you find Q over here, Q would come out to be a null matrix. And Q equals half of A minus A. What is that? 6 minus 6 is 0, minus 2 gets, everything gets cancelled. Can you observe that everything gets cancelled? This becomes a 0, 0, 0, 0, 0, 0, 0, 0, 0. That's a null matrix, and which is equal to this matrix over here. Therefore, since, can you observe that P plus Q is equal to P plus Q, matrix P plus Q is equal to 6 minus 2, 2, minus 2, 3, minus 1, 2, minus 1, 3, which is the matrix A. Hence, have we expressed the matrix A as a sum of symmetric and skew symmetric matrix? Yes, this is sum of symmetric and skew symmetric matrix over here. This is our matrix A, as you can observe clearly. Now this is part 2. What about part 3? Can we continue and move on to part 3? Yes. This is part 3 over here. Now observe this part 3. Let's assume it as a matrix A, and next we'll solve using the concepts developed that symmetric matrix and skew symmetric matrix would be half of A plus A prime and half of A minus A prime. Okay. So let A equals this matrix 3 minus 2 minus 4, 3 minus 2 minus 5 minus 1 1 2, and A transpose would be equal to what? This is 3 3 minus 1 minus 2 minus 2 1 minus 4 minus 5 2. This is what I have. Let A equals this matrix and A transpose equals this matrix. Okay. Let P equals half of A plus A transpose and Q equals half of A minus A transpose. This will be symmetric and this will be the skew symmetric matrix that we require. Right. Therefore, P is half of the sum of these two matrices. Let's find the sum of these two matrices. 3 plus 3 is 6. This is 6. 3 minus 2 is 1. Minus 1 minus 4, the sum is minus 5. That's what we have. What next? Minus 2 plus 3 is 1. Minus 2 minus 2, the sum is minus 4, and 1 minus 5 is minus 4. Next, minus 4 minus 1 is minus 5. Minus 5 plus 1 is minus 4. 2 plus 2 is 4. This is the matrix P, which is equal to further 3, 1 by 2, minus 5 by 2, 1 by 2, minus 2, minus 2, minus 5 by 2, minus 2, 2. This is what I have, right? This is matrix P, which, as you can clearly observe, is a symmetric matrix, right? These two elements are same, right, across the diagonal elements, right? What next? And Q matrix is half of A minus A prime. What is that? Difference of the two. So let's take the difference by subtracting the corresponding elements. 3 minus 3 is 0. 3 minus of minus 2 is 5. Minus 1 minus of minus 4, that is minus 1 plus 4, which is 3. Minus 2 minus of 3 is minus 5. Minus 2 minus of minus 2 is 0. 1 minus of minus 5 is 6. Next, minus 4 plus 1 is minus 3. Minus 5 minus 1 is minus 6, and 2 minus 2 is simply 0. This is what I have. This is Q, which is further equal to what? This is further equal to, let's multiply with half, and what you get is 0, 5 by 2, 3 by 2. This is minus 5 by 2, this is 0, this is 3, this is minus 3 by 2, minus 3 and 0. This is what I obtain. And can you observe that matrix Q is a skew symmetric matrix? Yes. Diagonal elements, the other than diagonal elements, are negatives of each other. Observe that P plus Q is equal to what? The sum of these two matrices, P and Q. 3 plus 0 is 3. 1 by 2 plus 5 by 2 is 6 by 2, which is 3. Yes. Minus 5 by 2 plus 3 by 2 is minus 2 by 2, which is minus 1. Okay. 1 by 2 minus 5 by 2 is minus 4 by 2, which is minus 2. Minus 2 plus 0 is minus 2. Minus 2 plus 3 is 1. What about the third row? Minus 5 by 2 minus 3 by 2 is minus 8 by 2, which is minus 4. Minus 2 minus 3 is minus 5. 2 plus 0 is 2. And what is this matrix equal to? P is a symmetric matrix. Q is a skew symmetric matrix. The sum of these two matrices is equal to, is it equal to this A? 3, 3 minus 1 minus 2 minus 1. Yeah. This is equal to this matrix A, and hence we have written A as sum of two matrices. One of these is symmetric, the other is skew symmetric. These are the given matrices. That's this part for us. What next? Let's move on to the next part. What is the next part? This part over here. Following matrix are sum of symmetric and skew symmetric matrix. Okay. Let's express this also. This simple 2 by 2 matrix, which should be very easy to crack. Yes. This is matrix A. Okay. 1, 5, minus 1, 2. Implies A transpose would be equal to 1, 5, minus 1, 2. Okay. Can I find the matrix P equal to half A plus A prime, which is equal to half the sum of these two matrices? What is that? 1 plus 1? 2. The second element 5 minus 1 would be 4. Minus 1 plus 5 would be 4, 2 plus 2 would be 4, and let's divide by 2. This is 1, 2, 2, 2. Is it a symmetric matrix? Yes, this is a symmetric matrix. Observe, this is a symmetric matrix. And Q is equal to half of A minus A transpose. What is that? Half of, let's take the difference. The first element 1 minus 1 will be 0. The second element 5 minus or minus 1 would be 6. Third element minus 1 minus 5 would be minus 6, and 2 minus 2 would be 0 over here. What does that become? This is 0, 3 minus 3, 0. Can you observe that this is a skew symmetric matrix? Can you observe that this is a skew symmetric matrix, right? And the sum of these two matrices, P plus Q, if I find P plus Q, what is that equal to? 1 plus 0 is 1, 2 plus 3 is 5, 2 minus 3 is minus 1, and 2 plus 0 is 2. And is this equal to this given matrix? Yeah. So the matrix A has been written as sum of two matrices, one of which is a symmetric matrix, the other is a skew symmetric matrix, as you can clearly observe over here. That is all for this question, as you can clearly see, right? Let's talk about this question. Choose the correct answer in the exercises 11 and 12. Okay, 11 says if A, B are symmetric matrices of same order, if AB are symmetric matrices of same order, then AB minus BA is a, what kind of a matrix is this? Symmetric matrix, skew symmetric matrix, zero matrix, identity matrix. Let's see how do we approach this question. So A and B are symmetric matrices of same order. Given A is a symmetric matrix, implies A transpose is equal to A and B transpose is equal to B. This is given. A and B are symmetric implies this is the condition which is given. Okay. And we are supposed to comment about AB minus BA. And since the person is talking about symmetricity, then we'll have to check symmetricity first of all. Okay, let's check symmetric, skew symmetric first of all. Zero and identity we can check later on. But since one of the options is correct, maybe symmetric and skew symmetric are the possible answers. So let matrix C is equal to AB minus BA. Let C is a matrix which is equal to AB minus BA. Let us assume C is equal to this. Therefore, C transpose is equal to AB minus BA whole transpose. Yes, very simple. What else? Now transpose over sum or difference of two matrices and the whole transpose, the transpose will shift to each matrix, right? So this will become AB transpose minus BA transpose. Using the property of transpose, since A plus B whole transpose is equal to plus or minus B, this is equal to A transpose plus or minus B transpose. This is a property of transpose, right? And we are using this property of transpose. What next? The product AB and its transpose would be simplified using this property. This is B transpose, A transpose. This is a property. So this becomes B transpose, A transpose. Similarly, reverse the order and what you get is A transpose, B transpose. The transpose comes down and this is what you get. What else? We already know something about these transposes, right? At this stage, we can say that B transpose is equal to B, A transpose is equal to A. So this is some statement using one. So this is B, this is A, this is A, this is B using 1. This is using equation 1. Okay, BA minus AB. Now this BA minus AB, this is AB minus BA, this is BA minus AB. Let's take a minus common. This becomes AB minus BA, and can you observe that this is equal to minus of C. Now C prime is actually equal to, that is C transpose is equal to minus C over here, implies that this C is a skew symmetric matrix, and yes, that should be the correct answer. That is the correct answer for this question. That's a complete solution. Each and every step has been explained clearly. You can take a look at the complete solution. That is all for this question. Let us solve this question. Choose the correct answer. If A equals this matrix, then A plus A transpose is equal to identity matrix if the value of alpha. Okay, we are supposed to find the value of alpha. There's some kind of an equation in terms of alpha. What is the equation that is given? A plus A transpose is equal to I. Okay, A plus A transpose is equal to identity matrix. Now what is matrix A? This is cos alpha minus sin alpha cos alpha plus the transpose of this matrix, okay. This is cos alpha minus sin alpha, cos alpha. And this sum is equal to identity matrix, which is 1 0 0 1. Okay, we'll get 4 equations maybe, let's see. Corresponding elements, cos alpha plus cos alpha, 2 cos alpha is equal to 1. This is one equation. Minus sin alpha plus sin alpha is equal to 0. The minus sin alpha plus sin alpha, which implies 0 equals 0, gives us nothing else. Sin alpha minus sin alpha, which will be 0, it is also 0. Okay, very good. Cos alpha plus cos alpha is 2 cos alpha, which is 1. So this is the only equation that I am getting. This is the only equation which I am getting, and this implies that cos alpha would be equal to 1 by 2, and alpha can take various values. This implies alpha will be 2 and pi plus minus pi by 3. That's the general solution where n belongs to any integer. N belongs to the z. N is any integer, right? This is cos alpha is equal to half. This is true for alpha is equal to pi by 3, or that's the general solution. So which of these answers is correct? The correct answer is this option B. Alpha is pi by 3, right? That is all for this question over here. Yes. And with this we come to the conclusion of this exercise based on matrices. This is exercise 3.3 that we have just discussed with you.